So, welcome everybody to another episode of Software Architecture on Stream, this time around with Chris Richardson. Welcome, Chris, to the show. Chris, do you want to say a few words about yourself, what you're doing, and where you're coming from?
Oh, yeah, sure. Where should I begin? Well, these days, I sort of do everything. I just think about microservices all day long. A few other things, but it's sort of my area of focus for the past few years has been the microservice architecture. I mean, I actually started developing software like professionally back in 1982, if you can believe it, which was like that was my first paid job the summer before college. Programming an RPG on an IBM mini computer.
Wow.
And then I worked on Lisp implementation. After college, I worked on Lisp implementations and Lisp tooling for like 7+ years, and then eventually ended up into, in the Java community, which is where I've sort of stayed since, gosh, I don't know, forever, feels like. And then along the way, I wrote the book Pojos in Action. So that was all about building applications with Spring and Hibernate. That came out in 2006, and it's kind of interesting that I'm still using Spring and Hibernate. And then shortly after that, I created the original Cloud Foundry. So that was a PaaS for deploying Java applications on EC2. So you basically uploaded your WAR file, 11 clicks of the mouse, and it spun up a whole bunch of EC2 instances and monitored and managed them. And that was before AWS had the rich capabilities that it had today. But it was like learning about AWS back in 2006 just blew my mind, and I felt like I had to do something. And then I ended up, that got acquired by SpringSource and then VMware. And then that's where the name, not the technology, but the name of Pivotal Cloud Foundry actually comes from. Was my startup. And then for the past 7-8 years, I've been just helping organizations around the world adopt microservices through consulting and training. And I used to say I traveled, but for the past 18 months, I've just been sitting in my home office yelling at my computer screen.
I guess like most of us, yeah.
Like everyone else.
And the company you're working for is Eventrate, so that's what do you do? That's your consulting company?
Oh, yeah. No. Oh, so I sort of do two things. Well, you could sort of say three in a sense, right? So I have microservices.io. So that's like a set of resources for learning about the microservice architecture. I do consulting and training. And then Eventuate is my startup, and we've been working on a platform that sort of in a nutshell, it implements or makes it easy to implement some key distributed data patterns in a microservice architecture, namely sagas, which are a form of distributed transaction, and then also CQRS, which is useful to implement some queries that span services in a microservice architecture. Another way of looking at it is that it's all about enabling services to communicate in a loose and collaborate in a loosely coupled fashion.
That would probably be worth a stream by its own, I guess.
Absolutely, it's good stuff.
And I will definitely put a link to it in the show notes, as well as to your website about microservices, microservices.io. And you also wrote a book about those microservices patterns that the website is about, right?
Oh, yeah. Should mention that too.
Yeah.
So that book, I mean, it's Microservices Patterns from Manning, and sort of it's about the microservice architecture, when to use it, how to use it effectively. And it's sort of oriented around the patterns. So I forget how many, I mean, there's like, in the book, there's like 40+ patterns or something like that, which range in granularity from like large scale patterns like the monolithic architecture it's not an anti-pattern, by the way, and the microservice architecture, you know, and then then say health check is a sort of low level but quite important observability pattern. And so, and then there's everything in between, like Saga, API composition, CQRS, and so on.
Right. One thing I forgot, sorry about that. We won't have any sketch notes today, so that's unfortunate. But back to your book and your website about those microservices patterns. Why did you start that effort? What was the reason for doing that?
Oh, well, I find patterns to be, even though the word is sort of overloaded and maybe it got overused at a certain point, but I find patterns a really good way to sort of describe and reason about a technology. Because you sort of look around in the community, and you know, Neil Ford coined the phrase suck rock dichotomy, which is like, my favorite technology rocks, yours sucks. And so we're sort of divided up into these sort of polarized tribes where, you know, neither side recognizes the benefits of the other tribe's technology or recognizes the deficiencies of their own particular favorite technology. And so, which is really not productive, right? We are an engineering discipline, and we should be treated more like an engineering discipline rather than a bunch of sort of, you know, tribes in a way. And so what's valuable about a pattern is actually the structure that it provides, right? So you know, like a pattern is, you know, it solves it's a solution to a recurring problem that occurs in a particular context. So context is the situation. You got the problem that you want to solve. You got a collection of forces or issues that you need to resolve, which might be conflicting. There's the solution. And then what's really important are the consequences. And there's three parts to the consequences. One is the benefits. So if you love a technology, you focus on the benefits, but you know, no technology is a silver bullet. So you also have the pattern describes the drawbacks as well, right? And so often we focus on whatever usually it's the benefits, because we talk about technologies that we like, right? But we have to think about the drawbacks as well. And then lastly are the issues, which are the problems that applying this pattern creates. So in other words, sub-problems, which you then have to resolve in order to successfully use a pattern, which actually and then the issues point to the patterns that offer possible solutions, right? So yeah, you look at them, you know, you sort of think about microservices versus monolithic architecture. It's like, how do we architect a system? I mean, there's numerous forces that we have to consider, but some of it is like rapid, frequent, reliable delivery of software, which I think we'll get to in a minute. And one possible solution there is structure the system as a set of loosely coupled services. And that has a bunch of benefits, right? Like super fast development, bunch of drawbacks, like, oh my God, we've created a distributed system, which is inherently more complicated than a monolithic architecture, right? And then there's a whole bunch of issues, like, oh, you have a command that needs to update data in multiple services. How do you do that in a way that maintains consistency? So that's a problem, right? And that would then be resolved by applying the Saga pattern, possibly. There's another pattern you could use. Or, oh, I got a query that spans multiple services. How do I implement that? And then you could use the API composition pattern or the CQRS pattern. So, you know, you apply a pattern that solves a problem, creates a bunch of sub-problems that you then apply other patterns to solve, which hopefully create smaller sub-problems So you like navigate this graph of patterns until you've sort of got a working architecture. And what's important there is that it's actually injecting objectivity into any discussion about a particular technology. Because like common question I get is like, the other sort of question I get is, well, I got this problem. Well, how do I solve this? Or should I do X? And my answer is, it depends, right? But that's, which on the one hand is like classic insulting answer, but quite often it really does depend, right? Because you have a problem that you need to solve. There could be multiple ways of solving it, and each one of those solutions has benefits and drawbacks. And so in a given context, you have to pick the pattern that is kind of like I want to say the least worst solution in a way, right?
I think that's a very good point that you're making there, that patterns actually have sort of guide you about how to think about architecture and to think in trade-offs. And therefore, I like the idea that you're doing all these patterns around microservices. And the reason why we are sitting here, or the sort of, the reason basically is also that you're doing a keynote for the software architecture gathering next week, and there is a discount code that I posted on the chat. And the organizers of software architecture gathering were so generous to help organize the session that we're having right now. And that keynote also talks about patterns. So that's great. And as you said, it talks about patterns for rapid, reliable, frequent, and sustainable development. Why these characteristics? I mean, there is a multitude of characteristics. So you could talk about, scalable systems or fail-safe systems. Why have you chosen these characteristics for your keynote, to focus on these?
Oh, well, I think, say, one of the big drivers behind, say, the adoption of the microservice architecture, and it's sort of a problem for, say, IT in general, right, is we in IT need to deliver software much more rapidly, frequently, and reliably, right? And also then there's a sustainability issue, right, where applications we build that are successful live for a long period of time, and we need to be able to upgrade the technology stack, right? And then you might be wondering, well, why do we need to deliver software rapidly? Oh, that is loud. I live on a quiet street. Why do we need to deliver software rapidly, frequently, and reliably, right? And so you could say there are two trends driving that, right? One is software is central to how businesses sort of offer their products and services, right? That wasn't necessarily true in a lot of domains, so many years ago. But now software is everything, right? Like, airlines, on the one hand, it's about planes and stuff, but on the other hand, it's like the mobile app on my phone is how the airline engages with its customers, and even their staff have tablets and so on, right? It's all software is there. And then also, the world in which we live is extremely, or the marketplace within which businesses operate, and more generally, the world is extremely dynamic and unpredictable, right? Boring examples of that is, you're a traditional brick and mortar bank, suddenly you have to deal with 10 competitors, digital only banks, because the government has deregulated banking in your country, right? That's one example. And then, oh my God, there's pandemics. What the heck? We have to deal with pandemics, which has had a dramatic impact on IT, right? Yeah. I mean, going back to the airline example, they suddenly have to deal with kind of like the whole issue around whether, international flights in particular, like whether a passenger would actually get let into the country. Do they satisfy the vaccination or testing requirements, right? And so their IT systems have to be enhanced to support that. That's just one sort of simple little example. So that means that, you know, because of the importance of software and because of the importance of, you know, the unpredictability of the world, we in IT have to deliver software much more at a much faster pace in order for our respective businesses to be competitive.
Also, the abstract says that coordination and communication with other teams should be minimal. And I think ever since we started discussing microservices in our industry, that's one of the reasons people gave for using microservices. Now, you could argue that, well, if you want to have less communication with other teams, first you have to have other teams. So microservices are only useful if you have a project of a certain size. So would you agree that microservices only make sense if you have multiple teams and if you have these kinds of problems and if you are working in a rather large project?
So yeah, I mean, there's a couple of sort of relevant points there, right? Is, you know, software is built by people, right? And then people are organized into teams, and there's sort of you know, one key issue is the larger the team, the more inefficient that team becomes, right? So there's a natural upper bound on the size of a team. And if you go look at that really excellent book, Team Topology, is basically which is almost like the Bible for how to structure your organizations for, you know, productive software delivery. It's like 5 to 9 person teams. For a whole bunch of like psychological, I mean, humans can only trust and work closely with a limited number of people, right? You know, and there's sort of fundamental psychological reasons for that, right? So that's one. So there's a limit on how big a team is, right? So yeah, so ideally you've got a small software, you've got a small, you only ever need a small team building your software. But a lot of software gets complex, right? You know, like typical use case, right? Or the scenario is, yeah, startup, you get a handful of people working together, right? And then, but if they're in a complex domain and they get VC funding, then suddenly you've got 200, 300, 400 people working on a project or on delivering the application. And yeah, sometimes software development is overstaffed, right? But there are domains that are actually quite complex and you need a lot of people, in which case, in that point, you need multiple teams. But it's really important that the teams are loosely coupled so that they're able to be productively working and not stuck in meetings, constantly coordinating and planning. And what was really interesting is before COVID, I was traveling around and it was universal. No company I visited had enough meeting rooms, right? My hypothesis is that they were tightly coupled, siloed organizations that constantly had to discuss and plan and align, right? And a lot of time was wasted, whereas what you need to do is restructure into these cross-functional teams, which are able to kind of go out and seek out requirements and actually turn them into, well, code running in production, right? So they're fully cross-functional, so you're eliminating handoffs. And ideally, the regular form of collaboration is your discussion is your daily stand-up, in that you rarely have to meet or coordinate with other teams. And the book Accelerate, which is sort of got fascinating research on high performance organizations, said in high performing organizations, developers can complete their work without having to collaborate closely or regularly and closely with people on other teams. And then you apply Conway's law to that, right? Loosely coupled teams, that requires you to have a loosely coupled architecture, because the architecture and organization tend to mirror one another. Right. So you need a loosely coupled modular architecture.
Right. And I took a note, so I will put links to the Team Topologies book and the Accelerate book into the show notes. But let's imagine that I have just one team of the size that you just gave, these famous 2 pizza teams that make everybody wonder what pizzas in the US are like. So let's imagine that we do have just one of these 2 pizza teams. Would you use microservices then? Because what you seem to be saying is that in your clients you see multitudes of teams and they need to collaborate, and there is this shortage of meeting rooms. So what do you think? If you have just this one team, would it make sense to use microservices, or is that just a question that you don't see in your clients because you only see clients that are so large that they have this problem?
Yeah, I mean, I would say if it's just a single team, probably not, right? Probably the monolithic architecture is sufficient, right? Like, I think the probability of I think the answer to this is multidimensional, but the probability of needing a microservice architecture is proportional to the number of people developing the application. And so for a small team, probably not. But I think, but like, say, one obvious example or counterexample, right, is maybe you need to use a mixture of technology stacks, right? Like maybe your core services or your core application is written in Java, and then for whatever reason, you need to write some part of your system in Python because it does machine learning, and another part of your system is written in Rust because Rust is cool. There can be technical reasons to actually use sort of build a distributed system, aka a microservice architecture. And then interestingly, going back to the original Cloud Foundry, right? So that application, I mean, had a UI, right? So as a user, I could click to upload and deploy an application and configure it, right? It also had a component that SSH'd into machines and configured EC2 instances and configured them. There was another component that was monitoring the instance status by polling the EC2 APIs. There was a monitoring and management component that was getting a stream of telemetry coming back from an agent that was installed on each EC2 instance. And then based on that, could be initiating auto scaling, implementing auto scaling, or some form of recovery. So it was actually a complex application made up of these many different parts, and there was 2 of us who developed it, right? And it was a monolith. I mean, it was a Java Spring web application, right? Yeah, tiny team, but complex application implementing a diverse range of functionality. And there would have been real value in functional decomposition, actually, in putting and using a microservice architecture. So there can be these scenarios when you've got complexity and diversity of function, that of actually using microservices for even when you have a small team? Most likely not, but the fact that there's numerous factors that you need to kind of consider when picking your architecture, or when assessing your architecture and deciding that it's time to evolve it to a more complex, from a monolith to a microservice architecture.
Yeah, there's probably no one size that fits all, and I would agree that for the original Cloud Foundry, probably a microservices architecture would have been more, let's say, more natural in a way. One thing that it's rather a detail of what you just said. You said that people might use Rust because it's cool, and that sort of reminded me about one of the how should I put it? One of the challenges that I have when discussing microservices architectures with, in particular, managers, because they seem to say, well, if we have that technology freedom, people will start off and they will just use technologies because they are cool, and then we have this huge mess, and that's of course bad, because we have so many technologies and nobody can make any sense of that anymore. So I guess you get the same question. So what's your answer to that? What do you think? How do you deal with that?
Well, yeah, on the one hand, I mean, that's the interesting thing, right? Is one benefit of the microservice architecture is that each service can use its own technology stack, right? And I think one huge benefit of that is coming back to the sustainability argument, right? We build applications that can last like forever, right? Or a really long time, and yet technologies come and go. Or even if you stick with a single technology, it keeps evolving, right? Java, the multiple versions of Java. And if you have a long-lived application, it's likely to be quite large, right? Like I sort of joke, developers on average add 50 lines of code a day, even though that's not the best metric. But applications have a habit of just growing and growing and growing, right? So if you wanted to upgrade the technology stack of an old application, you've got a very large code base. And it's something that you kind of have, it's an all or nothing thing, right? Upgrading from Spring version X to Spring version Y. Maybe that's not the best example because that tends to be backwards compatible, but then maybe there are maybe there are dependencies that require, I mean, I think one point I had clients who hadn't upgraded to the new version of Spring because that would have forced an upgrade of Hibernate, which would have taken, then they could never find the time to do that, which you could say is another problem. But the upshot is it's a big bang upgrade approach, right? Whereas if you're using the microservice architecture, you can upgrade one service at a time, which is a relatively small sort of task. And arguably, it's much easier to schedule, right? You can go to the project owner or the product manager or product owner and say, we need time in this sprint to upgrade to do this upgrade. And for a service size amount of work, they could probably say, sure, but for a monolith sized amount of work, probably not, or, much more hesitant. So that's one, I think, big benefit of the microservice architecture. And then, you could use it. You could then say every team should just use whatever technology works for them. But that does create unusual situations. I mean, I think at one time I remember one client I visited where one developer was implementing a key chunk of functionality and he literally chose to use Rust, right? even though the rest of the application was implemented in JVM using JVM technology. And so he just arbitrarily chose his own technology stack that was different from everyone else. And on the one hand, I feel like developers should be empowered, right? Like the other extreme is some unresponsive kind of architecture group that is glacial when it comes to approving new technologies, right? Like, I remember I've encountered one organization, they were not able to use Spring Boot because the architecture group had not yet approved it, even though it had been out for years. So that's the other, kind of the other extreme, right? Centralized control. And one approach that I think is really powerful is the one that Target were using, still are using, right? The technology roadmap, the list of approved technologies lives in GitHub. Developers can submit a pull request to suggest the use of a new technology. And then people can discuss it and, you know, vote on it. And then if it's sort of low, kind of a less strategic technology choice, say the developers can just easily approve it, right? Whereas let's say it's a new type of database, which sort of has enterprise implications, right? That could get escalated up to the CIO for them to, you know, +1 it, so to speak, right? And, you know, maybe there's a range of levels to need approval. And that, to me, I think is a powerful way of managing your technology roadmap, right? Where the teams, the engineers are collectively empowered to choose their technologies in a consensus-based way. And then at the same time, you do need mechanisms in place where product owners can be nudged, motivated to actually deal with technical debt, to deprecate old technologies, and not just focus on new features, because that's another sort of problem, right? So sort of deprecation or obsolescence should be a sort of, and tech debt in general should be something that's tracked at a high level, and product owners should you know, ultimately be motivated to reduce it as well.
I think what I like about what you just said is that you made this distinction between how should I put it, databases, which might even be a strategic decision, and day-to-day technologies, like, I don't know, some framework or some minor upgrade to some framework, and which basically means that there is probably no one answer to how to manage these technologies, but it really depends on what kind of technology you're talking about.
Yeah, you know, like say, yeah, you could say upgrading to a new version of Java. That's sort of a lowish level kind of thing, right? But deciding to use Haskell, for example, you know, that then creates a lasting sort of issue in terms of hiring, you know, long-term impact, right?
Yeah, or in your database where you would need to have some agreement with the provider for licensing and support, and you know, you would have to have some backup plan and disaster recovery and what have you.
Yes.
So Dude on YouTube made a comment, I think related to what we discussed concerning the original Cloud Foundry. So he said, right now I'm leading a small team in a factory business. The process of production is very complex, and we start adopting microservices because it's easier to model business needs. And I have to admit that I wonder what that means, business needs. There is no real explanation about that. And he continues to say it's easier also to deploy. I'm sure it would have been possible to do it with a monolithic approach, but we think it's a better fit for ramp up of new developers, which we bring which we plan to bring in place, or if we need to outsource just one use case which needs to be developed fast for the business, which basically says, sounds like we use microservices to enable loose coupling, right? That's probably what it says. But
yeah,
you might have some thoughts about it, because or you might want to comment about it.
Well, yeah, I mean, I feel like there's sort of there are numerous reasons to break things up, and sort of complexity and team autonomy are one. The idea of like outsourcing a service, right? I mean, like, imagine you have there's a chunk of functionality that you need implemented, right? Maybe in DDD terms, that's like a supporting domain. You can't buy it, you need to implement it, but it's not your core domain. There's something appealing about outsourcing the development of a service, right? It has a REST API, for example. It has its own database. So it's this self-contained chunk that's sort of independent, like loosely connected, but and independent from the rest of the system. Whereas if you said just outsource the development of this Java module, right? You know, and they give you a jar file that you then integrate in. Yeah, but it's not as cleanly separated and as cleanly self-contained as an independently deployable service. So that sort of outsourceability is kind of appealing. Plus, it can have its own repository, and you don't have to outsource the organization access to your primary GitHub repositories and things like that.
Yeah.
Another example, right? Which, you know, most of us don't have to deal with this, right? But some domains are heavily regulated, right? Like, for instance, if you're building some SaaS software that's to do with in the medical field, right? And say, you know, you've got an application that's controlling a device that's delivering drugs to a patient, right? You can't develop that using regular DevOps, right? Canary deployments can't be used when human lives are at stake, right? And there's a whole bunch of regulations, ISO, blah, 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 and it slows you down, right? So, you know, it's useful to segregate and regulated software from non-regulated software, because many parts of your SaaS platform can probably be deployed using regular DevOps at a much higher velocity. And then the one part that's figuring out dosage and so on, that's the slow regulated approach.
And that's a very good point, because I think that, let's say, that level of loose coupling is just not achievable if you don't use something like microservices. However, concerning that outsourcing scenario, what I'm wondering is, when you use outsourcing to sort of get a first version out quicker, then eventually you will probably have internal people take care of what has been provided by that outsourcing partner, and at that point you have some kind of handover. So if you use microservices, that might even, and you have this loose coupling, and you let that outsourcing partner just go and do whatever they like, and be more free and less and have less coordination, you might end up in a situation where it's harder to later on maintain it with internal people, right? So what do you think? Is that that a scenario that you see in clients with where they outsource the development of one microservice or several microservices,
Well,
and how do they deal with that insourcing later on?
yeah. I mean, you're right. I mean, there are issues. And interestingly, I mean, I have worked with clients where almost all of their software development was outsourced, and which to me is like trying to an organization that's outsourced heavily and is trying to adopt the microservice architecture. It is sort of, I mean, it's not very practical, right? Like to me, to be honest, I mean, to me, either you build it yourself or you buy or consume buy a product or you consume a service. To me, this sort of outsourced development is kind of like no man's land, so to speak. You know what I mean?
Actually, I'm not entirely sure. What do you mean, no man's land?
Well, it's not a desirable thing to do.
Oh, I see. Yeah. So ideally, you want to take care of the development with your own people.
So it's either you build it yourself or you quote buy it, right? Buy a product or consume a SaaS service, and yeah, there's sort of a whole bunch. I mean, sometimes obviously you got to do what you got to do, but
it's not ideal.
Yeah.
I think I would agree, and I think it's probably the better choice to take some developers and use them in your teams as an external resource, and use that approach instead. What I find interesting with the discussion that we're having right now, and also to me it feels like there is an industry-wide trend that basically says, okay, we've come to the realization that microservices are not the silver bullet, and now we are talking about monolith and other types of architectures again, after we thought that microservices are such a great solution to everything. Would you agree? And do you think that we learned something from microservices that we can now apply to monolith? Because quite honestly, there are certain monoliths that I've seen in my career that I rather would not want to see again. So it doesn't seem like such a desirable architecture either.
Well, yeah, I mean, you know, I sort of, gosh, I think I had a presentation about this, like, I don't know, 6+ years ago, about, you know, the Gartner hype cycle, where, you know, new technology comes out, it rushes up to the peak of inflated expectations, and it's wonderful. And then reality sets in, and then the inverse happens, and it plunges into the trough of disillusionment, right?
Right. Yeah.
And you know, and I feel like, and then eventually you end up to on the plateau of enlightenment. But those are the rough stages, and one hopes that, you know, I've been saying this forever to the point I'm like blue in the face, right? You know, monolithic architecture is a perfectly good choice for a lot of applications, right? It's just that, you know, when you start development, you need to evaluate numerous criteria and pick your initial architecture, which is usually the monolithic architecture. Sometimes it's the microservice architecture. And then constantly throughout the life of the application, you need to do some architecting, right? You have to ask the question, does my architecture satisfy the application's non-functional requirements, right? Which, in addition to the usual sort of scalability and performance concerns, which are very customer facing, right? It's like, are you satisfying your development time non-functional requirements. And, you know, I go back to sort of rapid, frequent, reliable, sustainable delivery of software, right? And certainly from the velocity point of view, there are some key metrics, which are like deployment frequency, right? You know, how many times per day are you doing deployments, right? And the state, and, you know, if you want to have a nimble IT organization, then arguably you should be aiming for multiple deployments per day, right? And ideally, you know, when a developer commits and pushes their changes, that change should just be built, tested, and deployed into production within 15 minutes, right? And that, you know, that then leads back to sort of architectural requirements, right?
Yeah, and that is also what the Accelerate book says, and there is a lot of, it seems there's a lot of scientific research to back that up. However, you know, what I'm wondering is, before we went live on the stream, I think you said that nowadays you see yourself, you notice how you're thinking so much about loose coupling. And if you are thinking so much about loose coupling, I guess that a monolith that you do nowadays is probably different from what you would have done like 5 years ago. And probably the reason why I think you're thinking about loose coupling is microservices, because, you know, you did all the work on the microservices. So I'm wondering whether you think that is something that the industry also does, and what is it that, and if you agree, what is it that you would do differently now if you would build a monolith now?
So, yeah, so my sort of model of software is, I mean, this goes back to the Accelerate book, like, you know, did I say this earlier, right? Where sort of one of the key characteristics of development in a high-performing organization is, I'm a developer, I can get stuff done, first off, without having to constantly talk with people on other teams, but also without, and then sort of related to that, without I can make changes to my component or whatever that is, without forcing other teams to make changes to theirs, or without requiring other teams to make changes to support my work, right? And that's actually, and so loose design time coupling is a key architectural requirement if you want to achieve rapid software delivery, right? And to a large extent, I sort of, that's sort of independent of microservices versus the monolith, right? I mean, terminology I use is a team works on a subdomain that's a mod or a module that's a chunk of business functionality, right? Or in other words, it's a bunch of Java, let's say you're in Java, it's a bunch of Java packages, and it has an interface, it has interfaces, and it is loosely coupled with other modules or subdomains, right? And that's from a design time coupling, that is the primary form of loose coupling that you want to strive for, right? So first and foremost, doesn't matter whether you're using the monolithic architecture or microservice architecture, teams need to own a loosely coupled chunk of software, right? But then sort of, then it's like, how do you physically package that up into a form that's executable, right? And so one extreme is the monolithic architecture where everybody's modules end up being packaged together into one WAR file, executable jar, so on and so forth, right? And that's the simplest architecture because it's non-distributed, right? And you have no issues with transactions or runtime coupling or anything like that because it's packaged together. The problem you have is, as the system grows in complexity, can you build and test it and quickly, right? I mean, you've sort of given up on any sustainability because you can't do incremental upgrades of your technology stack. So that's an inherent limitation of the monolithic architecture. But from a development time perspective, yeah, at some point, certainly when it's small, I can get my changes quickly into production. But as it grows and grows and grows, you do have this problem that if you're all contributing to the same code base, getting changes into production does get slower and slower and slower, right? I mean, you can have a complex, you can throw a bunch of technology at parallelizing your builds, right? You know, extreme example of that is Google with their mono repo, and they have PhDs working on their build system.
Yeah, and
which to me is, yeah, that's kind of interesting, but brains should be applied to generating true business value. No offense to anyone at Google, but your build system shouldn't, to me, it shouldn't be a source of, it's not a competitive advantage from a business point of view, right?
Yeah, and after all, we just can't invest these kinds of brains on these kinds of problems because we are not Google.
And then the interesting issue is you could say there's two flavors of monolith, right? Like the one that I remember building way back in the beginning is I make a directory, I CD into it, I make dear web, make dear domain, make dear persistence, right? And then I create a build, a Gradle or Maven or Gradle build file. And then that's the beginning of years of development, right? So that organization is horizontally layered, right? So if I'm working on order management, I own code inside web, inside domain, and inside persistence. But it's hard to work independently of that, right? But another organization, which kind of goes back to how would I do it today, you could have a modular monolith where the top level organization is actually domains, right? So, and then within side domains are the sort of the layers. So I'd make dear order management, make dear customer management. And then I think that facilitates independent development. And then I could take that a step further. And instead of having a mono repo, which actually and there's some serious issues with scaling that, right? You know, large teams all contributing, you know, you got 400 developers committing once a day into a mono repo. Even getting your changes into production is a slow process, right? Because you do a git pull, run the pre-commit test, do a git push, someone else might have already committed their changes and you have to keep doing that over and over again. So you end up having to implement a merge queue, yet more technology. So another approach is to actually have a repository per domain, and each team contributes to that. And then each domain has their deployment pipeline, which then feeds into an application deployment pipeline that then assembles the application and deploys it into production. There's a certain level of testing and validation there. And there's some sort of interesting issues as to, okay, order management worked fine in isolation, as did customer management. When I deploy them together, are they still going to work fine, right? You could have class path conflicts and you get no such method errors, right? You could have Spring application context naming clashes, right? I mean, there's a whole bunch of global stuff that makes sort of Java modules not always easy to compose together. But assuming, and you might have to do some testing, which ends up being a bottleneck, right? But having a modular monolith that's scattered over multiple repositories, I feel like lets you use the monolith architecture on larger projects. I'd love to hear from people who are doing this or who actually think I'm talking nonsense.
So,
especially within the next week, because I'm giving a presentation on it next week.
I think what I like about what you're saying is it seems like a continuum, right? What you're saying is that, or that's at least what you seem to be saying, or what I hear. So there are microservices which give me a lot of loose coupling, and then there is the possibility to have a monolith but separated repos, and then you can have one repo and a monolith. And the other thing that I took note of is that you said that the monolith should be structured by domain on the top level, not by layers.
Yeah.
And I think that's a very valid advice. What I'm wondering now is, so we spoke about the original Cloud Foundry and that it was a monolith, and that you started working on it with two people. And I'm still wondering what sort of the lesson learned from all the microservices and all these years. I mean, the original Cloud Foundry, it's like 10 years ago or so, right?
So I know, I'm living in the past. Yeah.
No, what I'm wondering is, so with this decade of looking at microservices, new architectures, and these kinds of things, how would you architect, with the two of you, how would you architect Cloud Foundry nowadays, today, if you would start the same project again?
Oh, yeah. I mean, so I sort of outlined various sort of chunks of functionality, right? Like UI/console, configure, like assuming I was using that era technology, EC2 instance configuration, the monitoring and recovery component. I could imagine deploying each one of those separately as services. I'll give you an example, right? Because like one issue was partway through, I mean, this is sort of a reflection on how bad my code was, right? But hey, we're all developers and we do things we're not proud of, right? Sometimes in hindsight. But for instance, you know, in the middle of configuring an EC2 instance, you go and redeploy the software, right? That actually interrupts the configuration of that EC2 instance, even though it was changing something in the UI, right? So that was, you know, that, and so separate deployability of the provisioning component and the UI component, which was more dynamic, would have been hugely valuable, right? To avoid that kind of, you got to redeploy everything and interrupt things that are in the middle of working, of doing things problem, right? And then this is the most embarrassing thing. The monitoring and management part was actually built using a stateful complex event processing engine, right? It was doing, the stream of events was flowing in and it was doing kind of, quote, complex analysis. It was stateful, which meant you could only have one instance of it, right? Because it was embedded inside a monolith, you could only have one instance of the monolith. You know, okay, that's kind of awkward, kind of embarrassing, and maybe you don't have that problem, but it sort of like illustrates some of the issues that you can kind of run into inside of, you know, with a monolithic architecture, right? And so splitting up can address those key issues. One key thing I want to point out is, you know, one problem we have is this term microservice, right? I think it's totally misleading because it makes you think you got to have lots of little services. And sort of one common anti-pattern that I've seen is basically one service per developer, right? Just numerically speaking, right? I mean, there's extreme examples, like I think Monzo Bank actually have 10 services per developer. But time and time again, I've seen this situation where it's roughly one service per developer. right? Whereas the reality is, in order to achieve team autonomy, you only need to have one service per team, right? Which is a much more coarse-grained architecture than I think a lot of people imagine it should be, right? And a team should only own more than one service if there is a tangible engineering reason for them to do that, right? One, well, maybe it's because it's like Java and Python, right? You got to have two separate runtimes. Or maybe because we actually, this domain that we're working on can be decomposed into two loosely coupled sort of subdomains or sub-subdomains, and we only need to change one of them usually, which means we can just build, test, and deploy that, and so sort of halve the lead time. But you shouldn't just gratuitously create new services. And the interesting thing is like organizations with super slick infrastructure, they make it easy to create services, which is good, but I feel like that gets abused. Because then if you have lots of services, you now have the problem of complex interactions between the services and more complex testing. And then because it's sort of like client will come to me, well, we're having problems testing our services. And then I go talk to them and it's like, they've got 5 services that they need to do consumer-driven contract testing of. But if they just merged them all into one, they'd eliminate the problem in its entirety.
So I think what I like about what you just said is, first of all, that you're proposing more, let's say, coarse-grained microservices, and this lower limit that one team should have at least one microservice or about one microservice. So I think that's very valuable input. And the other thing, what I found interesting is the discussion concerning the original Cloud Foundry, basically what you said is there needs to be there are these domains, and that is what you proposed, that you split your system by domain. And as soon as you add some non-functional requirements, for example, you gave the example of a deployment should not stop the reconfiguration, and you should have, or you want to have this separate scalability, because there is this one part where you're bound to have just one instance, but the others are easily horizontally scalable. And as soon as you add that, then it's very natural to do a microservices-oriented approach. And I think that's in particular interesting because there is an article, I have to dig it out, about the Istio service mesh in some IEEE magazine.
Oh yeah.
That actually says that talks about how they made it a monolith. So it's interesting that you come to a different conclusion for this specific problem of the original Cloud Foundry. So I think that's interesting.
Yeah, and I need to have a T-shirt that just says "It depends." Possibly
right. Yeah.
Word in there, because it really does, right? And so a while back I gave this talk, Dark Energy, Dark Matter, that sort of said, here's like half a dozen reasons why you should split things up, right? Kind of those are sort of repulsive forces between subdomains, and here's equally half a dozen reasons why you should not split, right? The sort of attractive forces, right? So sort of team autonomy is a reason to split, but then say runtime coupling or overall complexity is a reason to not split. And so, for any given part of your system, you have to evaluate the attractive forces versus the repulsive forces and think about it and make the appropriate choices.
Yeah, and I think you just gave a very good demonstration of that. And I wasn't trying to say that you were advocating microservices for everything. I think what you said is, well, this is how you split your system into domains on a conceptual level, and now if I add these requirements, then it's a microservices thing, and which is, I think, a good way to think about it and to reason about it and give like good reasons for these specific decisions. And I often lack that. Sometimes I don't see that in projects, that there are such clear reasons for architectural decisions. Yeah, a little bit over.
Exactly.
So that's probably so maybe it's not just it depends, but also you have to give good reasons.
It depends on certain factors that you have to consider, right? But
that's not something that you can put on a t-shirt, I guess. So we are slightly over time. Is there anything you like to add? Anything that I forgot to ask you about?
No, I feel like we covered everything. I mean, like, yeah, I mean, I feel like, you know, we should strive to architect systems that are composed of like simple components that collaborate in simple ways, right? As much as possible. And there are, you know, like numerous competing forces that we have to resolve. And like, if you go look at the dark energy, dark matter thing, and they vary from team autonomy to the impact of like runtime coupling.
Right.
And the importance of minimizing that. Because like one common anti-pattern is long chains of synchronous calls, which increase latency and reduce availability, right? And it's sort of, and so we've got to just, and part of that is careful design, carefully adjusting service boundaries. And if you build these gratuitously fine-grained architectures, the more likely it is that you will encounter problems. You know, like one final thought is, there's an expression, it's like, doctor, it hurts if I do this. And you know, the doctor says, don't. I feel like that comes up a lot with architecture, where you make a decision, right? We're going to split up the system in this way. That then creates painful problems for yourself, right? And so the answer is, don't do it, right? And so sort of part, you know, in a way, the role of the architect is like pain minimization.
And I think that's a very good way to put it. So thanks a lot. I'm really looking forward to your keynote at Software Architecture Gathering, and I'm glad that I had you on the show.
Thanks. It was fun.
Yeah. So thanks a lot. And there won't be a show on Friday, I'm afraid. So I guess the next one will actually be from Software Architecture Gathering. So we will have a few live events in the evening. So see you there.